Back guys, today we are back with another problem, and today's problem is maximum sum path in two arrays. Okay, so we will have two arrays and we'll be given two sorted arrays of distinct integers, array 1 and array 2. Each array must have some elements in the common with the other array. We have to find the maximum sum of a path. We have to find the maximum sum of a path from the beginning of an array to the end of the array. We can switch from one array to the another array only at the common elements. Okay. So let us try to understand this problem statement, exactly what it is saying. So say for example, we will be given two arrays. Okay, I'll quickly mark array 1. Okay, and similarly, I'll be having an array 2. Okay, so in array 1, I'll be having elements 2, 3, 7, 10, 12. Similarly, for this, I will be having 1, 5, 7, and 8. So as you can clearly see that I have two arrays 2, 3, 7, 10, and 12, and 1, 5, 7, and 8. So what I have to do is I have to check these points. Okay, I will tell you exactly how you can find the maximum sum as 35. So first I have to check. Okay, so I am in this region. So I am the array 1 and array 2. Whenever the element, so I'll be having a sum equals to sum 1. Okay, and I'll be having a sum 2 and an answer variable. Okay, so this is how I'll be working. So whenever I see that, okay, so 2 and 1 is there, which one is smaller? Whenever I am see that 2 and 1 is there, which one is smaller? What my initial task is that, okay, so since this is smaller, I'll be incrementing it to 1. I'll be incrementing it to 1. So what I'll be doing is initially I'll be putting for the two arrays, I'll be putting like this, that when the sum is like this. So I'll be putting sum 1 equals to 2 and sum 2 equals to 3, 3 equals to 1. Okay, so what I can do is I can remove this, yeah, and I'll be putting this as 1. So now I'll be doing the sum of the elements. So once 2 is done, what I'll be checking is, okay, so now I have 2 and 1, which is smaller. So since 1 is smaller, I'll be adding a plus 1 to it. I'll be incrementing this pointer to here. So I'll be adding 5. Okay. After that, I'll be incrementing this I pointer. So I'll be having an I pointer for this, a j pointer for this. I'll be incrementing the I pointer. So this becomes 3. Okay. So now my total value will become 5, and this value will become 6. After that, once this is 6, what I can see is, what is the next pointer? Next pointer is 7. When I increment this, next pointer is 7. But what I can clearly see is 7 and 7 both are common elements. So whenever I am checking, okay, so this is a 7 and 7, both are common elements. What my answer will store, so what my answer will actually store is the maximum value of this 5 and 6 plus the common element. Okay, so the answer will store 13. So right now my answer is 13. Okay, so let us check another. Once the answer is being checked, what I'll be doing is I'll be changing these values to update these values to 0. Whenever I'm finding a common element, I'm updating these values to 0. Okay. Now my pointer is at 8. Okay, so I will be checking 10 and 8. I'll be checking 10 and 8. So which is the smaller one? 8, right? So I'll be putting over here 8 over here. Okay, and when I've put the 8, I will be incrementing. When I put the 8, I'll be incrementing this j pointer. I'll be incrementing this j pointer. As you can see that there are no values left to this j pointer, I'll be computing the sum of the array 1. So I'll be adding 10, okay, and I'll be adding a 12. Okay, I'll be adding a 12. So I'm getting a 22. Now this is 8 and this is 22. So what I'll be doing is, in the answer I'll be adding maximum of 8 and 22, which is 22. So the answer which I'll be get is 35. Okay, as you can see, we are getting our answer 35. So let us now take an easy approach. This was the main approach how we are going to code this particular solution, but I'll explain you the problem statement as well one more time. So say for example, the array which I am given is 2, 3, 7, 10, and 12. This is my first array, and my second array is 1, 5, 7, and 8. So now if I have to compute the maximum sum path, what are the paths I can take? Okay, so what if I take this path 2, 3, 7, and 8? Okay, so this is my value, so this is my first array, and this is my second array. So if I'm taking this path, what is the sum I can get? 2 plus 3 plus 7 plus 8 till the common element I'm incrementing this part and this part. I can get a sum of 20. Okay, what if I take another path? Okay, 1 5 1 5 7 and 8. What if I just go here and then here? So I will be getting a sum of 1 plus 5 plus 7 plus 8 equals to 20. What if I take only this particular, you know, uh, what if I take this particular path, the path which says 1 5 7 then 10 and 12, which is my absolutely most optimal path, 7 10 and 12. So in this case I'll be getting an answer as 35. In this case I'll be getting an answer as 35. As you can see, the all possibilities I have calculated, but I have to find the path which is the maximum. So for the maximum path we will be using this particular technique. We can call this technique as a two pointer technique. In this technique we have array 1 and array 2. We have the sum. We will store the sum over here, the first array, sum of the elements of the first array and sum of the elements of the second array. Whenever we are encountering this particular scenario where both the elements are common, then what we are going to choose, we are going to increment the pointer and then make the initial sum as 0 and update the values. Okay, after that we have to do our rest of the solution. So I hope you guys could understand till this part. Now let us go to the coding and implementation of this particular solution to make our analysis even more stronger, so that we can solve this particular set of problem in few minutes time. Okay, so we have over here max sum path. Okay, we have a max sum path over here. So what my first task is to make the two pointers. Whenever you'll be giving a two pointer technique, make sure you initialize your pointers and then initialize the sum 1. Okay, initialize the sum 2 equals to 0. Okay, now I'll be having an answer equals to 0 for my answer value. Now I'll be checking what I have given the condition while my I is less than array of size. This is a base case. Okay, and my j is less than array 2 dot size. These are the base cases of the while loop. These are the base cases of the while loop which is going to traverse the to list. Initially you can see these are not an array, but this is an array list. So we can say that we have the list of integer type which is going to store this. Okay, so we'll be using a list data structure in this case. Now my first condition is if the value at I is lesser than the value of the second element, value of the first element at the second array. So what I'll be writing is if error 1 dot get, for array list we don't use the third bracket, so we are using this function called get I, which is lesser than error 2 dot get I. Okay, get j, sorry, because this is our second pointer. So we have made this two things. So we are going to update the sum 1 plus equals to, why we are using the sum 1, because whenever we have to see we have the lesser value, we have to update the value of the sum at that particular place. So sum 1 equals to error 1 dot get I. So it will add the elements of the first array. Okay, so once this condition is done, what I'll be doing is I'll be writing my else if. In the else if error 1 dot get I is greater than error 2 dot get I. Okay, so the else if part is done. What I can do is sum 2 plus equals to error 2 dot get I. So I made the sum 1 and sum 2 initialization perfectly done. Okay, now what about the else part? I will be also having an else part. So else part basically signifies that I have to move the pointer. Whenever I'm doing the sum, I have to move the pointer to the next element. So I can write like this: sum 1 plus equals to error 1 dot get of I plus plus. So that means if it is not small, so that means what I can logically think, this is the case of mutual element. So only one element in this particular array, whenever it is traversing, it can see 7 and 7 is there. So in 7 and 7 is there, then the sum 1 and 2 gets iteratively updated. So I can write sum 2 plus equals to error 2 dot get of j plus plus. Okay. So when we use a while loop, this entire things becomes so clear and so easy to understand that you will automatically feel the code. You will not feel demotivated while learning something. You will feel and you will try to understand each and every step while you are doing. Okay, so what we can see that we have computed the sum in this case. So, and also we have to update our result, right? So we can say answer plus equals to math.max of sum 1 comma sum 2. As I already told you, if you haven't seen the previous part, go back and see the explanation. I have explained you why we are doing this. Once we have updated this maximum value, I have to set the values as 0. I'll be exactly doing what I have explained in the pseudo. So you guys don't feel the pressure that, okay, this is not something which he has explained or not something which I'm unable to grab at it. Okay. So the else part is done. I'll be closing the while loop. Once the while loop is completed, what I can do is I can have another condition, add the remaining elements, if any, okay, in ARR2. So what I can do is while this is my initial base condition, j less than ARR2 dot size, okay. So what I'll be doing is sum2 plus equals to ARR2 dot get of j plus plus by moving the pointer ahead, okay. While loop is also complete. Finally, what I can do is my answer. In the answer, I can plus equals to math dot max value of the sum1 comma sum2. Okay, I've taken the math dot value of the sum. While loop is done, I can return the answer. Okay, so this is this. I have one extra, so I'll remove this. I'll remove this. Let's compile our solution. This was an easy two-pointer technique. It is saying while 49, it is saying we cannot find ij. 49, 49 while cannot find symbol I less than ARR dot size. Sorry, I have to use ARR1 dot size. So you have to be very careful while you are coding. So sum plus equals to ARR1 dot get I. So we are seeing we have to use sum1. So let's do this. Answer plus equals to int cannot be dereferenced. Sum1 dot. I have used a dot function, so I have to change this dot to comma. Okay, so let's compile. It is telling that we are getting a time complexity error. Time complexity error. What it is? We have to check. Maybe we are using a so just fixed some error was there. So what you can see that in case of some we have just done the code exactly the same. We have taken sum1 array over here, sum2 array over here, and else part also we have done carefully by updating the sum in the case of the mutual elements, and then we have updated the answer values and we have set it to 0 and we have added the remaining values as well. So yeah, this was today's problem statement. I hope you guys could understand. Let me just submit. And we are looking forward to solve more problems in the future. Make sure you like, share and subscribe to this particular channel. Thank you so much. And if you haven't seen the code, here is the snippet of the code. You can just take a screenshot or you can just code it in your IDE. Thank you so much. See you in our next video.